Academy. Today we are looking at IGCSE maths questions, selected questions from different papers and different years. So without much ado, let's begin. Okay, the first question, we can term this question number 6. In our previous video, we did question 1 to 5 from various and from different papers. So we can term this question 6. Okay, we can term this question number 6. Now this question says we will give you some numbers sequence 22, 17. We will give you some numbers 22, 17, 12, 7, and 2. So if you look at it, you will see that the sequence is decreasing. You see from this number to the next is decreasing with what? With -5. So every time it decreases with -5. Okay, so from 22 to 17 it reduces. So here we say -5. Put -5 here because it's reducing. Reduce with 5. So -5. From 17 to 12, also another -5, right? So another -5. So we will now say it's same all through. It's same all through. Also here to here, it's -5. It's -5. So it is correct to say that the common difference is -5. The common difference D is -5. So it's correct to say that. Now let's see what the question wants from us. Okay, so for this question, D is equal to -5. Is equals to -5. D is the common difference between first term and second term, and between second term and third term, between third term, this first term, second term, third term, fourth term, fifth term, and so on and so forth. Now the first question says we should find the next term of the sequence. We should find the next term of the sequence. So how then do we get the next term of the sequence? We'll just say 2, this last one, because to get when we're given first term, to get the next one, we just -5 from 22. We get 17. So after getting your second term, you want to get the third term, you subtract 5 from 17, you get 12. If you want to get the fourth term, you subtract 5 from 12, you get 7. If you want to get the fifth term, you subtract 5 from 7, you get 2. Now if you want to get the sixth term, you do same thing. You say 2 minus 5. You say 2 minus 5. If you want to get the sixth term. So you say 2 minus 5, which gives you -3. Which gives you -3. So this is what they want us to find. They say we should tell about the next term. They gave you a dash here, you put the answer. So the term is -3. The next term is -3. In some questions, they ask you to find the next 2 terms. So if they ask us to find the next 2 terms, some questions, but for this question, they only want this. Once you write this, you get the 1 mark. So this one is -3. It's -3. But if we want to expand or we want to exceed a little bit, they say find the next. Let's assume they ask us to find the next 2 terms. So we simply do another -3 minus 5. We say -3 minus 5. We get -8. That will give us -8. So if we do that, we'll get -8. We'll get -8. We'll get -8. So if they have asked us for another term, the term would have been -8. But for this question, it's just the next term. So the next question, the big part of the question says we should find the end term of the sequence. We should find the end term of the sequence. Okay. For every basic arithmetic sequence, we have different types of sequence. We have arithmetic sequence, we have geometric sequence, we have quadratic sequence, we have cubic sequence, and so on and so forth. We have various and different types of sequence. For basic linear and arithmetic sequence of this nature, what the end term is simply given as, we say end term is equal to, there's a formula for it, a simple formula for it. N term is equal to A. A is termed as the first term. We use A, this letter, as first term. A plus bracket, A plus bracket, N minus 1 D. N minus 1, then we close the bracket. N minus 1, we close the bracket, and then we multiply with the common difference. So this is the formula we use for finding the N term. A plus bracket, N minus 1 bracket D. So if you know this formula, then everything is done for you. Now what is A? A is the first term. A is the first, so A is 22. A is what? Is 22, because it's the first term. So we can bring it out. A is 22. Our common difference for the sequence, is negative 5. So D, once you know A and D, then you find the N term. Our D is negative 5. Our D is what? Negative 5 for the sequence. For this sequence, our D is negative 5. So once you know A and D, you know A and this D, you substitute. You don't need to know N. In fact, that's why they ask you to find the N term. Okay, so N term, the next is to substitute to this formula. N term is equal to A, which is 22, our first term. You put 22 here, our first term, plus, then you open the bracket. You don't know N, so write it down the way it is. You write it down the way it is. Say N minus 1, close the bracket, then multiply it by D. D is negative 5. So I put negative 5 in place of D. Then the next thing I will do, I'll use this negative 5 outside the bracket to multiply inside this bracket. You know there's no number here, so here is just 1. So you don't use here. You use this one, negative 5 outside this bracket to multiply this bracket. So what do you have here? You write your 22 plus, this will be plus and minus, eventually it will be minus. Negative 5 times n, you get a negative 5n. You get what? Negative 5n. So you get minus 5n. Why? Because this negative 5 multiply this n. That's how we got this negative 5n. Then the next thing is negative 5 times negative 1. We'll get positive 5. Why this one become positive? Because this negative multiplied by this negative. Negative 5 multiplied by negative 1, we get positive 5. Okay? So now we write 22 plus 5, we'll get what? 27. This number and number, we add them together. Number and numbers, we add together, right? Numbers and numbers, we add together. So 5 and 22, we add them together. So 5 plus 22, we get 27. Minus 5n. This plus minus will become minus anyway, eventually. Minus 5n. So this is the n term of this sequence. This is the n term of this sequence. So you write here 27 minus 5n. It is also correct if a student write minus 5n plus 27. Okay? Don't think the student is wrong. So if a student write the minus 5n first, before he writes 27, it's still correct. Let's say if a student you write the answer like this, minus 5n plus 27 is also correct, okay? It's also correct. So it doesn't matter which one you write first, whether you write positive 27 first or you write it the second time, then it's still fine. So this one you get your 2 marks for doing this. Now let's go to functions. Let's call this question number 7. Okay, question number 7. So for function, this is usually grade 10 topic, functions. So it's easy. Okay, you have to listen. Sequence is grade 8, grade 9, and grade 10. Sequence is both in grade 8, grade 9, grade 10. Okay. So for function you can even learn this one. The beginning, especially the beginning, is very easy. Now let's take a look at function. F of x, they give you f of x equal to 2x minus 1. And they give you g of x, 3x minus 2. They give you h of x equals to 1 over x, what? Is it x squared? 1 over h of x, 1 over x. Is it x raised to power 2? Or 1 over x? It's just 1 over x. I think that one is comma. Okay. 1 over x. And j of x equals to 5 raised to power x. Okay. So find f of 2. So what that means, f of 2, what it means anywhere you see x, substitute it with 2. Instead of say f of x, where x is, the position of x, replace it with 2. That's the meaning of f of 2. So you remember f of x. We remember f of x. Remember f of x is equal to 2x minus 1 is equal to 2x minus 1. So if we say f of 2 now, meaning in place of x, we've replaced with 2. If you say f of 2, what it means is in place of x, you replace it with 2. So if you do that, this will become what? 2 multiplied by 2. Because in place of x, we're going to replace it with 2. It becomes 2 multiplied by 2, then minus 1. 2 multiplied by 2 is 3. If you subtract 1, you get, 2 multiplied by 2 is 4. If you subtract 1, then you get 3. So our answer is 3. See, it's easy, right? That's why I say it's easy. This is like primary school thing. So when I say it's great, don't feel it's a big deal. It's easy, so our answer becomes. So this is a basic function. But this one is a composite function, the second one. G of s, g f of x2. G f of x2. This one is composite. It's called composite function. Okay, for those who are very familiar with function. So what this one means, first of all, I'm going to find, before I do g f of x2, we're going to do what we call g f of x first. Let's simplify g f of x. Before we now replace that with 2. Before we replace it with 2. So let's find the g f of x. Now what this means, we read it the way you read Arabic. Okay? Like you move from this side to this side. You substitute f of x inside g of x. We're going to put f of x inside g of x, meaning you're going from the right to the left, like the way you do berry. You know berry, when you do berry. Okay, we're going to put f of x inside g of x. Okay, we're going to put f of x inside g of x, meaning what that means, take a look at g of x. G of x is 3x minus 2. So I'm going to take the whole of this f of x, the whole of this 2x minus 1. I will use it to replace x in g of x. In place of x in g of x, I will take the whole of f of x and put it in place of that. So what that means, this will be equal to, I'll write 3, this 3 for g of x. I'll write the 3 out. Now the place of x, I'm going to take the whole f of x. I'm going to take the whole of f of x and put it inside g of x. So this 2x minus 1, I'll use it to replace x. This whole 2x, you take the whole of f of x, which is 2x minus 1, and put it in g of x. Put it to replace x in g of x. So I will put here 2x minus 1. 2x minus 1. Then we close the bracket. And then we now say minus 2. Look at minus 2. What we do, we put the whole f of x to replace x here, to replace only this x. This 3 is this 3. Then this minus 2 is this minus 2 we are writing now. So that's what it is. This is called the composite function. You put one function inside another function. You put the one on the right inside the left. You put the one on the right inside the left one. So now the next is to expand. We expand this, we get 3 times 2x, we get 6x. If we expand 3 times 2x, we get 6x. And then 3 times minus 1, we get minus 3. Minus 3, and then this minus 2. This one is not going to be multiplied because it's outside the bracket. You just write your minus 2. So eventually, this function becomes what? It becomes 6x minus 5. This one becomes 6x minus 5. That's not the end of it, but this is the end of the simplification. But remember, they say we should find fg of 2, meaning in the end, replace the x with 2. Replace with the x with 2. So this will lead us to 6 times 2. That's in place of x, you put 2 there, it becomes 6 times 2, then minus 5. Then minus 5. So you have 6 times 2, you get 12. 12 minus 5, we get 7, right? 12 minus 5, we get 7. So this composite function equal to 7. So you get this, you also get another 1 mark. Okay? This one is supposed to be like 2 marks because it's a bit intense compared to the other one. So this one is 7. So we go to the next one. It's called inverse. G raised to power minus 1 of x is called inverse of inverse function. You know, we have normal function, composite function, and inverse function. So now let's take a look at the inverse function. Okay? Inverse, first of all, write the g of x. What's the g of x? G of x is 3x minus 2. So we write g of x. G of x equals to 3x minus 2. 3x minus 2. Then, before we start, we make an assumption. We replace this one with y. We say let y equal to g of x. We just so that it's easy for us to deal. Okay, f of s, g of s, whatever it is, you can replace them with y. H of s, whatever it is. So you say let y equal to, okay, I don't want to write that, but I'm saying it. Let y equal to g of x. So here, before you start asking how do we get y here, it's an assumption. We just assume. We just replace it with y. So it's easy for us to solve. Okay, we say y equal to 3x minus 2. The next step, there are steps. Okay, the first step is to let y equal to g of x. The next step is to interchange position. We want to swap position. I want to bring, you see this x, I put it here, this y, I put it here, interchange. So the next thing we do what we call interchange x and y. The next is to interchange the position of x and y. Interchange the position of x and y. Interchange the position of x and y. So interchange x and y. So what I will do, it's not like you want to make the subject. Just interchange. Take x here, put here. Write it here. So here I have x. Then where x was before, I will put y. Instead of 3x, I will now have 3y here. That's what we call interchange their position. Minus 2. After you have done interchanging of position, then you now make y the subject. Now make y the subject. Make y. After you interchange your position, you make y the subject. Make y subject. Subject of formula. Make y the subject of formula. Make it stand alone. Make it the boss. Okay? Make y the subject of formula. So after you've done that, you say x, you bring this 2 minus 2. When it comes here, it becomes plus 2, right? So you say x plus 2, x, I will move this one to this side because we want y to be on one side. X plus 2 equals to 3y because we want to make y the subject. equals to 3y. After that, you divide both sides by 3 because you want y to be the boss. So after that, divide both sides by 3. So we divide here by 3, we divide here also by 3. So we divide this place by 3, we divide this side also by 3. So if you do that, we'll get the y function. Y will be equal to x plus 2 over 3. So you now found out that y equal to x plus 2 over 3. X plus 2 over 3. Okay? So in the end, this y become the inverse. This y, you now say also will be equivalent to the inverse. The y that was g of x will now be g inverse of x. So if that is g inverse of x, you write your final stage x plus 2 over 3. So this is your inverse function, x plus 2 over 3. You do this, you get 2 marks. You get these 2 marks. Okay? We can do it without, you can do inverse by just normal thinking, like without solving, but you will not get the 2 marks, except it's a multiple choice exam. So you can look at the function and do the inverse. Inverse means the opposite, somehow. What this means, this one, you just add them, whatever is here. This multiplication will become the division. So it was 3x minus 2, right? You become x plus 2. We can do it without even solving it over 3. This was multiplication, it will become division. 3x will become s plus 2 over 3. Anyway, that's just that. But the solving, which you need to show in the exam, is this way. Now let's go to the next, the C part of the question. I hope we'll get the scope. Let's go to the C part of the question. We say find x when h of s equals to j minus 2. First of all, when h of s, let's write the h of s out. H of x is 1 over x. So h of s is 1 over x. When is equal to j of negative 2. What's j function? j of x is 5 raised to power x. So where 5 raised to power x, where x is, you put negative 2. So I will have 5, instead of 5 raised to power x, because they say j of minus 2, I'll have 5 raised to power minus 2. I'll use the negative 2 to replace the position of x. So instead of 5 raised to power x, I'll replace it with this one, 5 raised to power minus 2. So this one, I'll put it in indices form, this one. So this one will be rewritten as 1 over x will be s raised to power minus 1. Right? S raised to power minus 1. Or you can say, okay, we can simply say, okay, a better way to do this, we say 1 over x is equal to, this 5 raised to power minus 2, you put it in this format also. It becomes 1 all over, anything raised to power minus, it becomes 1 all over in indices. 1 all over 5 squared. The minus will disappear, 5 squared. So if something is 5 raised to power minus anything, minus means 1 all over. This minus makes it 1 all over 5 squared. So now you have the next stage is 1 all over x equals to 1 all over 25. 1 all over x is equal to 1 all over 25. 1 over x equal to 1 all over 25. If you have anything like this, x equal to 25, just say x equal to 25. You know why? If you cross multiply x times 1, you get x, and then is equal to 1 times 25, which is 25, so s equal to 25. So when you have something like this, you just finish it up by writing s equal to 25. So you get another 2 marks. These are, mind you, these are from IGCSE past paper, Cambridge IGCSE past papers. Okay? So you write down, when you go through the past papers, you can use these answers to fill them up. And also, you should be able to solve it by yourself by then when you open the past papers. Okay, now we move on to the next one. We move on to the next one, which says, write f of x minus h of s as a single fraction. Now, f of x, we remember f of x is 2x minus 1, right? 2x, f of x, 2x minus 1. 2x minus 1. Then you now say minus, what's our h of s? We go and check our h of s. I think it's 1 over x. Right? 1 over x. 2x minus 1 minus 1 over x. Say we should write it as a single fraction. So this one you do small algebraic fraction. See? This function, we are doing algebraic fraction, and small things. So write it as a single fraction. So you find the LCM of the denominator. The LCM of the denominator is x. The LCM of the denominator is x. X. Why is it x? Because x times 1 is x, the denominator. X times 1 is x. 1 times x is x. So LCM of the denominator is x. So you will not take this denominator, LCM, to divide each of the denominator. So x divided by 1, we get x. This x divided by 1, we get x. Then we use it to times this. Whatever we get, we use it to times this. So x times this, we get 2s squared. 2s squared minus x. 2x squared minus x. Then we take this one to divide this one. X divided by x, we get 1. X divided by x, we get 1. 1 times 1, we get 1. So we write this minus 1 here. We extend this one to reach. So this is the single fraction. So this is the final stage. 2x minus 1 over x. So this is our answer. 2s squared minus x over x. This is a single fraction. Is that okay? So this is our answer. 2x squared minus x minus 1 over x. Over x. We get another 2 marks here. If you can do this, we get another 2 marks. Then let's go to the E question of this number. It says find the value of j of 2. j of 2 means substitute j of x inside j of x. And then eventually you use 2 to replace x. Substitute j of x inside j of x because we're moving like this from the right to the left. You're going to substitute this j of x inside this j of x. First of all, what is j of x? Let's see. J of x is 5 to the power of x. So I'm going to put I'm going to put 5 to the power of x in this box. In this box, where x is supposed to be, 5 to the power of x, I'm going to put another 5 to the power of x here. I'm going to substitute another j of x inside. So I change the color so that it will be conspicuous enough. So we're going to put another 5 to the power of x here. So there's 3-level layer of power, or 2-level layer of power. 5 to the power of 5 to the power of x. So in indices, or index, or logarithm, this x will come to the back. 5 to the power of 5 to the power of x becomes x 5 to power x. S times 5 to power 5. How? How? Because this one comes to the back. This one comes down. And then we now have 5 to power 5. This one comes down here, becomes x multiplied by 5 to power 5. 5 to power 5, what do you get? 5 to power 5, that's 5 in 5 places. 5 times 5 times 5 times 5. 5 to 4 places is 625. 5 to 5 places, what do you get? 3,000. Okay, this will give us 3,125. 3,125x. So we get 3,125x. Okay, for this one. And they say we should substitute for, in place of s, put 2, right? J of 2. So I'm going to multiply this one with 2. So I'll say 3,125 times 2. 3,125 times 2. What do we get? If you multiply by 2, 3,000, you're going to get 6,200. 200 and what? 50. 250. Is that okay? So we get that. Now we move on to the last of this question. Okay, we move on to the last segment of this question. Let's see what this segment has to offer. It's a find x when j inverse of x is 4. Now let's see j inverse. The j inverse is 4. What's the inverse of exponent? It's same, right? The inverse of this exponent is the same thing. Find j inverse of x. Find x when j inverse of x is 4. Okay. Wait, let's see this one. J inverse of x is 4. The inverse will be the inverse of an exponent or indices will be logarithm. So if we say log, and log are in base 10. If we say log 10 5, this is the inverse of this one, equals to 4. So if you do logarithm, this x will come to the back. You get x log 5. So I no need to write the base 10. I just write s log 5 equal to log 1000. 4 is 1000. For ordinary number, 4 is 10,000 with 4 zeros. How? Because if I ask what's 1, 1 is log 10. Log 10 equal to 1. If you press your calculator. Log 10, the log 10, they are all naturally in base 10. Log 10 is 1. Log 100 is 2. Log 100, press your calculator, press log 100, you get 2. Log 1000 is equal to 3. Log 1000 equal to 3. So 4 is 10,000. So since they gave us 4, I'll write log 10,000. Okay? So we divide both sides. Is that okay? So we find x from here. Divide here by log 5, divide here by log 5. So divide here, both sides by log 5. So I have here over log 5. Even if I don't write log 5, it means because all these log are in base 10. So log 5, divide here by log 5. Also divide here by log 5 in order to find x. Divide here by log 5. So this one we cancel this one. Only x remain on the left. Then log 10,000 divided by log 5. Log 10,000 is 4. Log 5 is what? What's the value of log 5? This is 4 over. What's log 5? Press log 5. 0. Okay. 0.698. So 4 divided by 0.698, what do we get? That would be the value of x. 5.7. Okay, so that's the value of x. So we get another 2 marks. We get another 2 marks here. Okay, now let's move to another question. We completely out of this one. This is question number 8, right? We will be solving question 7. Now we are at question number 8. Okay, you say y equals to 3x squared minus 12x plus 7. This is a differentiation. Okay, in our previous video we talked about differentiation briefly. Y equals to 3x squared y equals to 3x squared minus 12x plus 7. Find the value of the y over the x when x is 5. Okay, first we differentiate this. Okay, we differentiate this. We explained differentiation yesterday. I used a simple example in our previous video. We say if y equal to x to the power of 3, if you are asked to differentiate this, you take this 3 to come to the back of x, you write 3x, the power comes as a coefficient. This power, you bring it as a coefficient. If there's anything here, you multiply it with anything that is already here. Then you subtract 1 from the power. It becomes 3 minus 1, which is 2. So the y over the x will be, if y equals to x cubed, the y over the x will be 3x squared. The y over the x will be 3x squared. So if they give us a polynomial like this one, if they give us a polynomial like this, so they say find the value of the y over the x when x is 5. So we differentiate it and substitute the value of 5 into the equation, we get the answer. So let's say the y over the x of this function, the y over the x, the y over the x of this function will be equal to, here you have power 2. Bring the 2 to the back, you multiply it with this 3, it becomes 6. 2 times 3 becomes 6, 6x. Since the original power is 2, you minus 1. So 2 minus 1 is 1, so we only have 6x. Then if you differentiate the one with power 1, you get only negative 12. You get only negative 12. Why is that so? We can show that if you differentiate a constant, you get 0. You differentiate because there's no x. So differentiation is something with x, y and x. You are showing their respect, one with respect to the other. Now, if you differentiate this one, why is it only negative 12? Because, you know, the function is 12x. 12x means there's power 1. X has power 1. If you bring the 1 to multiply 12 at the back, take this one to multiply 12, it will still be 12. It will still be 12. Then, here you have x raised to power 1. You know, I say always subtract 1 from the power. 1 minus 1. 1 minus 1 is 0. So you have 12 raised to power x raised to power 0. 12 multiplied by x raised to power 0. Sorry, 12 multiplied by x raised to power 0. And in indices, anything raised to power 0 is 1. Anything raised to power 0 is 1. So it becomes 12 times 1. It becomes 12 times 1. And 12 times 1 is equal to 12. So that's why when you differentiate any number with just x, you get that same number. So if you differentiate minus 12x, you get minus 12 back. So that's how we got this minus 12 here. So this is what we got. But you say find the value of the y over the x when x is 5. If x is 5, we substitute the 5 in place of x. After we differentiate, we substitute 5 in place of x. So I'll get 6 times 5 minus 12. 6 times 5. 6 times 5 minus 12. 6 times 5 we got 30. So you say 30 minus 12. 30 minus 12 you get 18. Right? Minus 12 we get 18. So this answer is 18. So this one is a cheap question with 3 marks. Okay, it looks as if it's hard, it's not. You get 3 marks for nothing, almost for nothing. Okay, you get 18. You get your 3 marks. Is that okay? Now let's go to the second part of the question. Is it find the coordinate of the point on the graph of y equal to 3x squared minus 12x plus 7 where the gradient is 0. Okay, where the gradient is 0. So we're going to differentiate this. After differentiating, we equate it to 0. You know the y over the s is the gradient. This is the y over the s. It's same as gradient. Change in y. The y means change in y. The s means change in x. Which is like you are saying y2 minus y1 over x2 minus x1. Okay, it's just the way you used to say delta y over delta x. So we differentiate the same function. We already differentiated it. We got 6x minus 12. 6x minus 12. Please pay attention. This is very important. They are now in Cambridge exam. They introduce it to differentiation and it's very easy. Now, he said, follow the instruction. He said the gradient is 0, meaning we should equate this one to 0. We should equate, because this means gradient. Because this means gradient. He said find the coordinate point. Coordinate means just find the s value and the y value. Now we want to find the s value. He said find the coordinate point on the graph of y equals to 3x squared minus 12x plus 7, where the gradient is 0. First, you differentiate this. I said the differentiation means the gradient. So when you differentiate it, you equate it to 0 because they say the gradient is 0. So you equate this one to 0. And you find the value of x. See? We solve this one. Because this 0 is equivalent to this dy over dx. This 0 has replaced because they say the gradient is 0. This one means gradient. This dy over dx means gradient. So we write 0 here. We say 0 equal to 6x minus 5. So you have 6x minus 5 equal to 0. Then you solve to find x. First you move 5 to the other, negative 5 to this side, it becomes positive 5. So you have 6x equal to 5. You move 5 to this side, it becomes 6x equal to 5. And then you say divide both sides by 6. X equal to 5 over 6. S equal to 5 over 6. Divide here by 6, divide here by 6. That's the value of x, which is 0 point something if you divide, if you want to put it in decimal. Right? Oh, sorry, why are we writing 5? It's 12, right? Sorry, it's negative 12. Here is negative 12. Here is negative 12. Sorry, okay? I was writing 5 instead of negative 12. When you differentiate, you get negative 12 here. Here is negative 12. So here is negative 12. Okay, so you bring negative 12 to the right, it becomes positive 12. So positive 12 divided by 6, you get 2. X equal to 2. Positive 12 divided by 6. Positive 12 divided by 6, you get 2. So we've gotten the value of the x. We got the s value for the coordinate. Now it's our turn now to find the y value of the coordinate. After you get the x, you take the value of the s and put it in the original equation to get y. Look at it. There's y function. You just put the value of x here. You substitute x here. You get your value of y. So take the original equation. The original equation is y equal to y equal to 3x squared. 3x squared minus 12x plus 7. This one is also from gradient. Pay attention. Those graded, what do you call that? This mathematics. So if you're grade 9, this is your work. Grade 10, grade 11, this is your work. Okay, so we say the next thing, we found x to be 2. So in place of x, I will be putting 2 so that I can find my y. So I have y equal to 3 multiplied by, in place of my x, I put 2. So I'll say 2 squared minus 12 plus 7. Plus 7. Now let's simplify this. We say 2 squared is 4. That means 2 times 2. That's 4. 4 times 3, we get 12. Okay, y equal to 4 times 3, we get 12. It becomes 12 minus 12. That's 0. 12 minus this 12, which is 0, plus 7. So our answer is 7. Because this 12, we cancel this 12. This one, we cancel this. So our answer is 7. So the y value equal to 7. So this is the coordinate of that point. So we get our coordinate point. So we get that as cheap as it could. Now let's go to the other question. This one, it looks big, but it's very simple. So let's take a look at this, but you need to pay attention. Okay? It says, this question says, when y equal to 2s raised to power p, you say y equal to 2x raised to power p plus q x plus qx squared, then the dy over dx, dy, the differentiated one, dy over dx is equal to 14 14x 14 14x raised to power 6 plus 6x. Now it's a find the value of p and q. That's the question. They gave you this. They want you to tell the value of this p in the power and the value of this q as a coefficient. So what do you do? See, this is a differentiated one, right? So we need to differentiate the one they gave us and use it to compare this one. We have to differentiate this one. Whatever we get, we use it to compare this. Now I want to differentiate it. Let's use a different color, to an orange color, to show it. So we can compare with this one. Okay? And then we'll be able to deduce the value of p and q. So we say the y over the x, the y over the x is equal to, let's differentiate this one. If you differentiate this one, this p will come to the back, right? It becomes 2 times p, that's 2p. Remember what we said before. It becomes 2p. Then we write the x raised to power what? Raised to power p minus 1. You know it's a formula. It's a formula. It's a standard formula. Raised to power, you now subtract 1 from the power. P minus 1. Then plus, we differentiate the second one. You take these two, bring it to the back, use it to multiply q. It becomes 2q. Becomes 2q raised to 2qx raised to power 2 minus 1 is 1, so no need to write 1 anymore, because it's supposed to be raised to power whatever is there minus 1. 2 minus 1 is 1. So in this thing, no need, in maths, no need. We just write 2qx. Now, after you've done this, you will now make comparison. Let's use a different color. We make a comparison between this one and this, so that we can find p. We equate them, and we also equate this and this in order to find q. In order to find q. So in doing that, we say 2p is equals to 14. If we equate this first one, 2p is equal to this 14. 2p, we say 2p equals to 14. So we divide both sides by 2, we get the value of p. So this divided by 2, we get p to be equal to 7. We get p to be equal to 7. P is 7. So it makes sense. You know why? 2 times 7 is 14. Now, 7 minus 1, you know, here is p minus 1. 7 minus 1 is 6. That's why this power is 6. Okay? So it makes sense. So p is 7. P is 7. Now let's find q. You say 2q. Let's change the color. Will be We say 2Q is equal to 6. So to find Q, divide here by 2, also divide here by 2. So Q equal to 3. Q equal to 3. Now, it makes sense because if Q is 3, 2 multiplied by 3, you get 6 here. That's how this 6 comes about. So Q equal to 3. You get your 2 marks for doing this. Okay? This is how we grow in IGCSE problems and we become a super giant in solving this problem. Now let's go to question 9. Let's go to question 9. Question 9 is on compound interest. Okay, so I think many of us are very familiar with compound interest. You say Carlos invests 4,000. So what you invest, the money you invest is your principal. So he invests $4,540. So that's the principal, $4,540. At a rate of R%. So the rate was not given to us. They just call it R. They didn't give a value. They say R%. Probably this is what they want us to find. Per compound interest. At the end of 10 years, so the time, which in the compound interest most of the time we use N. Or you can use T if you like. It's 10 years. At the end of 10 years, he has earned 1,328.24 in interest. So the CI, the compound interest he earned at the end of 10 years is $1,328. $1,328.54. Okay, so this is what he earned in interest. This is not the total amount. This is just the interest he got after investing this money. Now he said calculate the value of R. Now, first of all, we must bring out the formula. The formula is amount equal to the principal into 1 plus R raised to power N, number of years. Because this is an appreciating compound interest. If it's a depreciating compound interest, we use minus here. Okay? So, but we are looking for R. And we don't know the amount. We cannot have two unknown. We have to find the amount and substitute here so that we can find R. So, but we remember the formula that collate amount and principal. Amount equal to principal plus the interest. The money you invested plus the interest you get from the money is equal to your amount. So we will add the principal, which is 4,540. We'll add the interest. So if we add the interest, which is 1,328.54, 328.54. If we add them together, we'll get 5,000 something, right? 5,868. We'll get 5,868.54 as our amount in dollar. Okay, so this will be our amount in dollar. So now we know the amount. Now we can solve the problem. So we come here, we substitute this value for the amount and solve the problem. So we say 5,000, which is the value of amount. Amount means the total money he received at the end of 10 years. 5,868.54 is equal to the principal, which is 4,540, into 1 plus R. We don't know the value of R. R, is 100%. We would have said over 100. But we just leave it like this. At the end, when we finish, we multiply our answer with 100. Okay? When we finish, we multiply our answer with 100. Then we raise it to power 10 years. So the next step is to divide both sides with this one. We divide both sides with this amount, with this principal, 4540. 4540. Divide here by the principal and also divide here by the principal. 4540. So if you do that, this we cancel this one. And if this one go into this, we get 1.29. So equal to 1 plus R raised to power 10. 1 plus R raised to power 10. So when we reach this stage, is to find the 10th root of both sides. So to find the 10th root of this number, you key in your calculator. So when you get to this place, pause the video, key this in your calculator, and try to do this. The 10th root of this number, and also the 10th root of this one. Okay, so we have 1 plus R here. Everything raised to power 10. Raised to power 10. Okay, this one, we cancel this one. Okay, we get what? 1.02, we can say 0.26. So we approximate the next 1.02, right? 6 equal to 1 plus R. So we subtract 1 from both sides. Subtract 1 from here, subtract 1 from here. Or you just move this one to this side, become negative. So R becomes 1 minus 1.026. 1.026 minus 1. So R becomes 0.026, right? 0.026. Now at this junction, you remember I said we're going to multiply whatever we get with 100 because we didn't put it here before. So we multiply this with 100, we get 2.6. So our rate, R, is 2.6%. That was the rate they gave the guy for the investment. They must give you a rate to calculate your interest. So this is the rate they gave him for the investment. So if you're able to do this, you get another 3 marks. If you cannot do this, then you're not supposed to be in grade 9, let alone grade 10 or 11. Okay, that's just on the lighter side. I'm just playing. What it means is that you should practice. Okay, when you get to grade 8 in some good international school, you're supposed to be doing compound interest. Okay, so now we move to question 9b. Question 9b. Okay. Now we have this. You say the volume of the is a cube, right? Cube. Cube means all sides are equal. Okay, even it's not drawn to scale. That you see, they will tell you it's not drawn to scale, so that you not say, oh, this one is longer than this one. No, it's not drawn to scale. They already told you, but they've used the words and they've told you what it is. It's a cube. It's a cube. Cube means both the height, the length, and the width, they are all equal. They are all same. So if the length is y, the width will be y, and the height will be y. So if you're looking for volume of, if they give you, the volume will be y to the power of 3. Okay, if they give you one side is y, the volume is y to the power of 3. Because it's a cube. All sides are equal. Now, it said the volume of the larger cube, this is a similarity. The volume of the larger cube is 5 centimeters greater than the volume of the small cube, of the smaller cube. Show that this is this. Now, what it means is that volume for large one, large one is y plus 1. Y plus 1. To get the volume, you raise it to power 3. Okay, to get the volume, because every side will be y plus 1. Even here will be y plus 1. Here will be y plus 1. The width is y plus 1. The height, this height is y plus 1 also. Because it's a cube, all sides are equal. So to find the volume of this large one, you will say this y plus 1 times this y plus 1 times this y plus 1. So you get the volume. So to put it in a simple form, you just say y plus 1 to the power of 3. To the power of 3 is equal to, you say the volume of the larger cube is 5 centimeters greater than the volume of the small one. So it's 5 centimeters greater. So I'll put 5 centimeter cube. Centimeter cube greater means plus whatever the volume of the small one is. The volume of the small one side is just y. So the volume will be y to the power of 3 because the width is y and the height is also y. So volume will be y times y times y, which is y to the power of 3. So here I'll have y to the power of 3. Y to the power of 3. Is that okay? So we solve. After this, we just begin to expand and begin to simplify, and till we get, till we're able to prove, we'll show this concept that they've given us. So the first thing to do is to expand this one. So this one, it means, so let's focus on this one first. Okay, I might just draw something like this. Okay, just to. So we say this one is same as say y plus 1 in one bracket multiplied by y plus 1 multiplied by another y plus 1 then multiplied by another y plus 1. That's what this one is. That's the meaning of y plus 1 raised to power 3. Meaning 3 times. Okay, you repeat this one 3 times. So the first thing we do is to expand the first two. But if you want to do it one time, it will be cumbersome for you. So you do this first two as usual. Y times y becomes y squared. This y times y is y squared. Then you say y times 1 is y. So I write plus y here. And then I take this plus 1. Plus 1 times y, I also get another y plus y. Because 1 times y is y. 1 multiplied by y is y. Then 1 multiplied by 1, I get plus 1. So if you do this first two, you get y squared. Y plus y is 2y. Just like you say, 1 orange plus 1 orange is 2 oranges. So y plus y is 2y. So I write 2y here plus 1. 2y plus 1. So I have expanded this one. So I will now expand whatever I got, I will use it to expand with this one. So I bring another bracket. Let's use another color. We bring another bracket. We expand with this one. Another y plus 1. So what this one means is that I will take y, I'll take this y, I'll use it to expand the whole of this. Before I take 1, I use it to multiply the whole of this. So y multiplied by y multiplied by y squared, I get y cubed. Y multiplied by y squared, I'll get y to the power of 3. Plus y multiplied by 2y, I get 2y squared. 2y squared. Then y multiplied by 1, I get y. Then I'm done using y. Now I'll use 1. 1 multiplied by y squared, I'll get y squared. I'll get y squared. 1 multiplied by 2y, I'll get plus 2y. One multiplied by 1, I'll get plus 1. Not 2. So if some student will write 1 times 1 is 2. No. It's not plus. You are not adding there. It's 1 multiplied by 1. You get 1. Okay, now you collect like terms. This one is a load. The highest power is only 3. It's only 1 time only. So we write y to the power of 3. Now we see that, okay, in collecting like terms, I think we should change the color. Okay, y to the power of 3. Then you have 2y to the power of 2. 2y squared plus y squared. You get 3y. It's like you say 2 oranges plus 1 orange, 3 orange. So here I'll get plus 3y squared plus 3y squared. Okay, now here I have y plus 2y. I'll get 3y. Y means like 1 orange plus 2 oranges. I'll get 3y. Okay, plus 1. There's nothing to add to this one. You just say plus 1. So this is the expansion. This is the volume of the large one. This is the volume of the large cube. So you now equate, you bring it here, we equate it to this one. Let's rewrite it. We say the new volume now. The volume of the large, V large, okay, before I write it, let's say V large equals to 5 V large is equal to 5 plus V small. 5 centimeter cube plus V small. Remember, that was the concept. Plus V small. V large, this is the volume of the large one, equal to 5 plus, this is the volume of the small one. So the V large, we've got an equation for it. We've expanded it. We got y to the power of 3 plus 3y squared plus 3y plus 1 is equal to, now we equate it to 5, this 5. Okay, let's change the color. Equal to this 5 equals to this 5 on the right, plus what's the volume of the small one? The volume of the small one is only y to the power of 3. So I will say plus the volume of the small one, which is y to the power of 3. Now we go to collect like terms and we equate to 0. We bring everything to the left, we equate to 0. So first of all, I'll move this y to the power of 3 to come here, it become minus y to the power of 3. So here we have y to the power of 3, the original one here on the left, this one, Then I'll bring this one. I'll say minus y to the power of 3. I bring the one on the right to meet with it. So see, I bring this one to meet with this one. So they will cancel each other out. Then plus 3 plus 3y squared plus 3y, this 3y, plus 1 plus this one. Then this 5, we also bring the 5 to this side. It becomes minus when it comes to the left. You say minus 5. Everything now is equal to 0 because you brought everything on the right, you brought everything to the left. So equal to 0. So we say this one cancels this one. This one, we cancel this one. Because if you have an apple minus an apple equal to 0. So they cancel. So what is left is this one. So we have 3y squared plus 3y, this one, plus 3y, then you say plus 1 minus 5. That would be negative 4, right? 1 minus 5 is negative 4. Minus 4 equal to 0. So that's what they asked us to show. Look at it. We've got it what they want us to prove. That we show that 3y squared, this one, plus 3y, which is this one, minus 4, which is this one, is equal to 0. So we've gotten it. We get 4 marks for doing this. So today, this will be the end of today's class. And then we will continue from there. We have a lot of these IGCSE questions that we're going to be solving for all of you. And we hope that it benefits everyone who uses our video. Okay, thank you for joining us.